One good day, Algebra. We are covering PO20, which someday you will look back on this objective with fond memories and appreciation, maybe even save you 10 cents at Caribou in the long run. So I reordered the objectives for this year for some unknown reason because it turned out to be a lot more work than I thought it was going to be. I missed this one. It was not CO21. It was CO19 when we learned that slope and linear functions are connected. It's what we just did. It's what we just corrected for today. We learned that a linear function will always have slope, and if a function has slope, it will be a linear function. Okay. And when we start graphing stuff, we're basically going to focus on linear functions to start with, and then move on to parabolas later on in the year, somewhere around PO54 or so. Okay. So we're going to define slope. We did it yesterday. Yeah. Parabolas are graphs that either go like that or like that. Okay. They're a different type of equation, but we'll get to all that later on. Okay. Yeah. Put your hand up, Arlene.
Yeah, I was asking if it could
Joey?
be horizontal too.
What's that?
I was wondering if it could be horizontal.
So square root graphs. Here we go. 20 minutes. We're off topic. But square root graphs are kind of like the cousin to a parabola. They look like that. And the reason why is because you can't have the square root of a negative number. So we'll get to more about this. We'll learn about it in Algebra 2 when we cover it. But anyway, they can be, but they're not parabolas. It's a different type of equation. Right? Anyway, back to linear functions. Boring old lines. Okay. How do we define slope yesterday? How did we define slope yesterday? Yeah.
Wait, no, the rate at which a line moves across the coordinate plane.
All right. The rate at which a line moves across the coordinate plane. Okay. The rate at which a line moves across the coordinate plane. Same definition as yesterday. Okay. And I threw out the phrase rise over run to you yesterday, and most of you recognize that. We've got that here. We also, on yesterday's objective, defined slope as the change in y over the change in x, which is pretty much what this one says here too. How the line moves along the y-axis compared to how the line moves along the x-axis. There's a lot of different ways to describe or define slope. Okay, whichever one kind of clicks with you is the one that you should use. But truthfully, what we're looking at here is how the line moves vertically along the y-axis compared to how it moves horizontally along the x-axis. Okay, so last year, did you look at lines and identify their slope? Is that kind of how you? Okay, so what context really did you use slope in? Raise your hand, please. Raise your hand, and let me know. Bryn. Not at all? Well, how would you recognize the phrase rise over run then?
We don't. No, we
Shh, some of you, raise your hand. Raise your hand. Arlene.
In the entrance exam, we had to do slope and find the slope of a line, and I know the formula.
So the entrance exam was your first experience with any of this?
Yeah.
Yes.
So we know.
Kylie?
We did.
Shh, your name's not Kylie.
One time in science, I think that we did like a graph about something that we had to do slope.
Okay. Crinkle?
We did graphing.
So you talked about slope and a graph. Okay. Okay. Shh, raise your hands. Damien.
I don't think we ever went over slope.
Okay. Ellen?
I remember Rise Over Run, and I feel like Miss Bynum taught us about it, but I have no clue what she was telling us about.
Okay. Catherine?
Shh. I feel like you mentioned it, but you never really taught us.
Okay. All right. Well, we'll start from square one then. Okay. That's a good place to start anyway. Okay. So when you're looking at a graph, when you're looking at a coordinate plane, we know this is a linear function because it is a straight line. And we think about this definition, rise over run, change in y over change in x, how the line moves across the y-axis compared to how it moves along the x-axis. what we're looking for is to get from point to point, okay, and the points are labeled here for you. Essentially, how far do we move up the y-axis? What's the change in the y values, which in this case would be what? 2, right? We're going up 2. Yesterday, we wrote this plus 2 with a function table. You know, we looked at the change in the y. We're doing the same thing here, only now we've got a graph to look at. And the change in x is how far we move across the coordinate plane. How far do we go over? 3. Positive 3, right? Because we're going to the right. So the slope of this line is going to be up 2, that's the rise, over 3, that's the run. Or the change in y is plus 2, the change in x is plus 3, or how did it move along the y-axis? It went up 2. How did it move along the x-axis? It went over 3. Okay? So the slope of this line is going to be 2/3. And the nice part about this, like we talked about, slope with linear functions is constant. If we go up 2 and over 3 again, where are we? Right back on the line again, right? You can get any point on any line by following slope. Okay? Max?
Will they always like do the little dots so you know where it's
No, there won't always be the points labeled for you. But what you're looking for is where does this line like pass through a corner? You know, we wouldn't really want to use this point here because it passes through a side of our grid. We want to look for where it passes through a corner. So I've got these 2 points labeled for you. But where else does it pass through a corner that we could use if we wanted to? Jack, what's the order pair? On the second one there.
From 6 to 4.
What I'm asking here is I've got these points labeled for you, but if I didn't, you know, where does that line pass through a corner that we could use as a point as well?
The top corner.
Like up here?
Yep.
Yes, we could use that point. Kylie?
And then with it ends
the last.
Just give me the order pair. I heard 0, 5. 0, 5 would be right there on the y-axis. We could use that point. Okay. We could also use this one here. Looks like about 4, 3. We could use that point as well. Okay. But you're looking for where it passes through a corner. Right. But using the points that I've provided, again, we're looking for that change in y. So how far do we go down the y-axis here? What's our change in y, Alex? 2. And because we're going down 2, it's going to be a negative 2. The change in y is negative. We're going down. And then how far are we going across the x-axis? How far are we going to the right here? Kylie? 4. And it's positive 4. Right? Because along a number line, which is what the x-axis is, going to the right is positive 4. So the slope of this line is going to be negative 2 over 4. Okay? And as we talked about yesterday, this slope being a rate, negative 2/4, Vince, what does that simplify to be? I need you here, bud. Okay. What does the fraction negative 2/4 simplify to be, Beckman? Negative 1/2.
And does it matter if you have a little triangle thingy that you did on the top or
It does. I'll get to that in just a second here. Okay. So negative 2/4 being equivalent to negative 1/2. We know that if we go down 2 and over 4, we end up back on the line again. What happens if we go down 1 and over 2? Magic happens. Down 1 over 2, we're back on the line again.
Oh my God.
Right? Okay. If we take what's a fraction that's equivalent to negative 1/2, other than negative 2/4?
Negative 500, 1,000.
We're not going to use that one because it won't fit on the corner plane.
Oh. Okay.
Give me one that'll.
Negative 3/6.
Okay. So negative 3/6. right? If we start at, we'll say this point here, because we said that we could, it crosses through a corner. If we go down 1 over 2, we're back on the line again. We go down 2 over 4, we're back on the line again. We go down 3 over 6, we're back on the line again. Okay? Slope is a rate for how the line moves across the corner plane, and you can get to any point on a line by using the slope. Okay? Beckman asked the question. He was saying, with this little triangle that we make here, would it be okay to make it above the line like that? Okay? The danger with that is that if you do this, you say, okay, I'm going over 4 and down 2. Is over 4 down 2 the slope? No. Okay? The rise has to be the numerator. Okay? That vertical change has to be the numerator. Right? So, could you do it, Beckman, if you knew what you were doing? Yeah, but I would not recommend it. I would recommend always looking at that vertical change first, down and over versus up and over. Yes?
So will you always do down and then over, or like?
Either up and over or down and over. Yeah. Do that vertical change first. Okay? Joey?
You always have to go left to right.
Yes, you read a graph like you read a page. Left to right. Jack? Yeah. Why were we clapping in the middle of no? Okay? There are certain things you need to realize time and place.
Okay.
Yeah. Vincent?
Isn't it some books you read right to left?
What's a book where you read right to left?
Chinese books, yeah.
Okay. This is not Chinese math lesson. Okay. All right. What happens, though, when you are not given a coordinate plane? Who carries around a coordinate plane in their pocket, always ready and able to graph any equation? You do. I'm going to test this. When you go to lunch, I'm going to ask you to pull out your pocket coordinate plane and graph an equation. If you can't do it, then I get your popcorn chicken.
What?
High stakes. Then I get your dessert, whatever you brought. Right? Okay. 3, 2, 1. You are quiet. Crinkle, I did not call on you. Warning for you, because this is the second time you kind of just burst in. Because all of you who raise your hand are liars and you do not carry around a pocket coordinate plane. When I ask you to find the slope of a line containing 2 ordered pairs, unless you want to draw a coordinate plane, which gets dangerous because whenever you draw something freehand, there's the potential to lose accuracy. Or if you're given ordered pairs that with our numbers that are very large or very small, you might not have enough space. There is a slope formula. This is a key point. This should go on your help sheet, okay? And this is what you needed to know for the test, that it was extra credit, it didn't hurt you. This is also on the entrance exam, okay? Let's unpack, Joey, warning for you, this definition of change in y over change in x. What does that word change mean as far as an operation? When you look for how something changes, what are you doing, Arlene? The difference, which is the operation of subtraction. Okay? So if we're looking for the change in y over the change in x, if we're given 2 ordered pairs, x, y, first ordered pair, x, y, second, we're going to label these values, whatever they are, as our first x and our second, and our first y. Okay? First x and first y. Hold on, let me rewrite that. First x, big old comma, so you don't get confused by the ones in the comma, and first y. Notice how those ones are lowered. They're not powers. They're not exponents. It means an order. Our first x, our first y. This would be our second x and our second y. Okay? Yes. Crinkle. Good. Good. Okay. We'll just... Okay? And so the formula, if we're looking for the change in y over the change in x, what we're doing here, this is the actual formula. I'll write it in red here. We are taking our second y value, y2, and subtracting our first one. That's going to give us the change in the y values. And then for our x values, we're going to kind of do the same thing. We're going to take our second x and subtract our first one. That will give us the change in the x values, right? So for 3, 7, and 5, 10, our two ordered pairs, I'm going to go ahead and I'm going to label these. Here's my first x. Here's my first y. Here's my second x. And here's my second y. Right? Two ordered pairs, first x, first y, second x, second y. And then it becomes a matter of plugging these things into this formula here. Okay? My change in y values will be found by subtracting 10 and 7. y2 minus y1. My change in x values will be found by taking 5 minus 3. x2 minus x1. So the slope of this line, 10 minus 7 is 3. 5 minus 3 is 2. The slope of this line is 3 halves, or 3 over 2. Arlene?
Do we ever simplify that to a mixed number?
No, you would not simplify this to a mixed number, which actually isn't simplifying, it's converting. But you would not write it as a mixed number. The reason why we'll get to later on. You would not write it as a decimal either. Okay? You want to leave it as a fraction in simplest form. So 3 halves can't be simplified, but if it could, then you would want to. Okay? But we would leave it as 3 over 2. How you feeling?
Pretty good.
Okay? Let's look at -6, 4, and 10, -8. Again, we're going to start by labeling these. First x, first y, second x, second y. And plugging these into the formula, y2 minus y1 is going to be -8 minus 4, right? Since that y2 value is negative, you got to include it in the formula, -8 minus 4. And here's where things can get a little bit tricky. In this x subtraction here, my x2 value is 10. There's a subtraction sign in the formula, so I have to have that. And then my x1 value is negative, so I have to include that as well. Okay? And I heard someone say it's plus. What do you mean by that? Ellen?
So when there's two negative symbols, it turns into an plus.
Right. This notation, subtracting a negative, is the same thing as addition. Okay? And so our slope here, -8 minus 4 is a -12. And then 10 plus 6 gives us 16. Right? -8 minus 4 is a -12, and then 10 plus 6 is 16. Arlene asks earlier, do we have to simplify? This one can be simplified. So -12 sixteenths, you should simplify that to be -3/4. Okay? And that would be your final answer. Asking to simplify a fraction is like asking last year Mrs. Gregory if you should end a sentence with punctuation. You would never ask her that because the answer is an obvious yes. You never need to ask me, do I simplify my fractions? Because the answer is an obvious yes. Okay? Alex? If it does end up being a whole number, you can simplify to a whole number. If you want to leave the denominator 1, you can do that as well. Okay? I've got less than a minute left here. So for homework for tomorrow, I would like you to do the one we didn't do on this page and these first 5 on the second page. You can save these 6. We'll talk about them tomorrow. Okay, so stop here. Stop after you do 32, 10, negative 12, negative 15, and so forth. So finish the page we're currently on, and then the first 5 on the second page. Okay? Homework due tomorrow. Yes? Okay, save it for just a second then. Any questions, comments, concerns, complaints, comments, congratulations, or criticisms? Damien? You did. We ran out of time, so we'll do it tomorrow. If you all get your homework done tomorrow, you get 2 of them. Yeah, you probably will then. Probably will. Okay? All right, folks, that's how you math.